Welcome to your video talking about SI units, scientific notation, standard notation, and converting between units of measure. After this video is over, hopefully you will be able to identify basic SI units of measurement, define what an SI unit is actually, be able to identify the magnitude of these units by using prefixes, be able to write SI measurements in standard and scientific notation. And here's Jean-Luc Picard right down here saying, why would you use feet as a unit when the length of feet vary from person to person? My hero, Jean-Luc Picard, and you're going to get why that's a funny joke in a second. What is an SI unit? SI stands for Système International Unités, excuse my French. However, it is French for International System of Units. These units are agreed upon amongst scientists worldwide so that we can share our results with each other and everybody has a common language to discuss those results. So what are these units? So SI units, these are the units that we are going to use here in honors physics. Distance or length will be described by the meter, not the inch, not the foot, because those are all imperial units of measure, as Jean-Luc Picard thinks it's ridiculous. So our SI unit for length is the meter. Mass is going to be in grams, not pounds, not ounces, but grams. Time is in seconds. You're used to that because pretty much worldwide we talk about seconds. Volume is in liters, not ounces, not gallons, but the liter. Here are some derived units, and we'll talk about what we mean by derived units in a little bit, and what their SI units will be. Force, the amount of pressure in a given amount of space, is one way to describe force. Its SI unit is the Newton. Power is watts. Energy is joules. Current is the ampere or amps. And counting number, which we probably won't use in physics, but you will use quite a bit in chemistry, counting number is considered the mole. A mole of anything is 6.022 times 10 to the 23rd units, things. But I had to put a picture of a mole up there. So if we just use these basic SI units, some of the measurements would be incredibly large and some of them would be incredibly small. This is why we use prefixes to describe the magnitude of these measurements or describe the powers of 10 of those measurements. This table is on Schoology, so you do not have to pause the video at this point to take notes on it. But this is the common set of prefixes that we're going to use in this course. The blue line here represents your standard SI unit. It has a value of 10 to the 0, and 10 to the 0 is also equal to 1. Anything below the line, the number is greater than 1. Anything above the line, the number is less than 1. And they increase and decrease by powers of 10. So for example, if I want 1,000 meters, I have 10 to the 3rd meters. I have a kilometer of meters. If I want 1/1000th of a meter, then I see right here 10 to the negative 3rd is 1/1000th or 0.001, and I have a millimeter. And I just add the prefix in front, attach it to the SI unit on the back side. We're going to practice converting between these different units of measure. And there are two methods I'm going to show you. Method number 1 works really well if your measurements go from 10 to the 3rd to 10 to the negative 3rd. And if you notice here on this stair step, we added another step in there to represent 10 to the 2nd, and that prefix is the hecto, and that hecto does not appear on your table that is on this slide. You may have used this device before to describe this method. They call it the King Henry died unusually drinking chocolate milk method, and it's a stair step where you've got King Henry died unusually drinking chocolate milk. U represents your unit. That's your basic SI unit. And if I'm going down the stairs, I move the decimal to the right. If I'm going up the stairs, I move the decimal to the left. Left means the measurement or the magnitude of the measurement is getting larger. If I move it to the right, that means the magnitude of the measurement is getting This means that the magnitude of the measurement is getting smaller because you're going from large units to small units. Let's see how to use this staircase. So let's practice converting 100 kilometers to millimeters. And one of the first questions you should always ask yourself is, should my answer get larger or should it get smaller? So the bigger the unit is, the smaller the numbers will be because you're counting larger items. The smaller the units are, the bigger the numbers will be because you'll have more smaller items. So here's how this works. I've got 100 kilometers and I want to go to millimeters. So here I am at kilometers and I want to get down to millimeters, and I count how many stairs that I'm going to travel. 1, 2, 3, 4, 5, 6. So I'm going down the stairs 6 times. I move my decimal to the right. Here's where my decimal starts. So I go 1, 2, 3, 4, 5, 6. And that is the standard notation for the number of millimeters that I've got. I want to put this in scientific notation, so I put that decimal back and I count how many places I need to go to turn this number back into 1. And I went 1, 2, 3, 4, 5, 6, 7, 8 places. So I have 1 times 10 to the 8th millimeters. And whatever these two numbers are the numbers that are going to appear in front here. So I can rewrite this as 1.0 times 10 to the 8th. And that's the stair-step method. Let's look at the conversion factor method. So conversion factor method works really well if you've got units that are not on the King Henry staircase. You start by asking yourself the same question, should my answer get smaller or larger? And that's a double check for after you do your math. After you do your math, you can see if your answer makes sense. So let's convert 130 micrograms to grams. So I start here by writing what's given. If I go back to my chart, I will see that a microgram has the abbreviation of the Greek letter mu, and its power related to your SI unit is 10 to the negative 6. So that means that one SI unit is cut up into 10 to the 6 pieces, and each piece is a microgram. So the relationship between a microgram and a gram is 10 to the negative 6. So what I do is I say 130 micrograms times 10 to the negative 6 grams is related to 1 microgram. Getting these numbers directly off of your table. And I can make this into a 1 to recognize I'm multiplying two fractions together. I can cancel out the micrograms and I'll be left with grams. And my question was, did my answer get larger or smaller? I wanted it to get smaller, and it definitely did because this number is a lot less than 130. This is not appropriate scientific notation because I want this number here to be between 1 and 9.9. So I move this decimal 2 places over to the left. And when I do that, I add 2 to this particular exponent, and it turns to 1.30 times 10 to the negative 4th grams. And that's the conversion factor method. When I say conversion factor, that's your conversion factor. Conversion factor is just a fancy name for a fraction or ratio. So I hope this was handy. You might have rewatched it to help you with the assignment tonight. And hopefully the talk we had in class about this exact same PowerPoint was handy. And thank you so much. Have a wonderful evening.